Hey guys, here is a video for one of the practice problems for today. Super similar as yesterday, pretty much same process, just slightly different when you get to the end because we are going to involve some eyes in today's, which was not a thing yesterday. So let's go ahead and start this process here. The first thing I want to do for these problems is graph this polynomial on either your calculator or Desmos. Personally, for this particular purpose, I would choose Desmos. I have graphed it here for us on Desmos, and the goal is to see where there is like a really obvious root, meaning where do I hit the x-axis. And if you take a look right here, you will see that right here on this dot, we are at 3. So if we hit the x-axis at 3, 0, that means our obvious integer root, which is what they're asking for, whole number root, is going to be 3. So let's write that down. All right, and if I have a root at 3, then that means I'm going to have a factor of x minus 3, because remember, your signs have to be opposite. If this is positive, this is going to be a minus. If this was a negative, then this would be a plus. All right, so next up, we're going to go ahead and divide our polynomial by one of the factors that we know we have so that we can find the rest of our factors. So let's go ahead and set up over here. We don't know what this top part is because that's what we're trying to find, but we do know that we'll put a -3 right here in this box for the x minus 3 factor from here. And now we got to do a little bit of Polydoku. So x times what is equal to x cubed? That's going to be x squared. And then x squared times -3 is -3x squared. And this is when we run out of information and we need to look below to see what goes in the next box. So right now I have -3x squared, and according to this, I need to end up with a total of -3x squared. That being said, whatever I put in this box, it depends on what this one is, because these two together have to add up to this number. But the thing is, I already have -3 and they want -3. That being said, this has to be 0x squared. I'm going to keep it an x squared term because these two, the diagonal boxes are like terms, so even though it's 0, it is still our x squared term technically. So let's keep going then. X times what is going to be 0x squared? Well, that would be 0x, right? So technically it is an x term because x times x would get me an x squared, but because it's ultimately a 0, I need this number to be a 0. So then 0x times -3 is just 0x. And again, it is 0, but I'm keeping the x in there still, just so I know that I'm working with the x terms next. All right, so now I look at this x term and I'm like, okay, well, I need a total of 25, and right now I have 0. And these two diagonal boxes have to add up to whatever this is. So if this is 0 and I want 25, I need to add a whole 25x to that. All right, so now that we know that box, we can say x times what equals 25x? Well, that would be 25. And then 25 times -3 is -75. And we also know that there should be a -75 here just from this. This number always goes in this bottom right box. All right, so we have completed our Polydoku and we've divided our polynomials. And basically what we discovered is that x minus 3 times x squared plus 0x plus 25 is equal to this whole polynomial. Okay, I had a lot of people on the quiz. Now that I'm making this video kind of late, I can say this, but a lot of people on the quiz just took this whole thing and put it in here, and that is not what you want to do. You take the gray part and put it in here. All right, so here comes the next part that's slightly more tedious, I guess. So we want to use this factor right here to figure out the rest of the factors. Right, because this one's not fully factored, it's still a squared, and we want all of our factors to have just x in them. So we take this and we have to do the quadratic formula, which let's remind ourselves what that is. Oops, that's not right. Let's try that again. b squared minus 4 times a times c all over 2a. This is our quadratic formula, and we have to use this polynomial. So let's go ahead and select our a, b, and c. So we have a is going to be 1, because there's technically a 1 here, imaginary. We have b is 0. It's weird, but it's okay. And c is going to be 25. And now we are ready to plug into our formula. Let's go ahead and start that down here. So we have, and maybe let's do it while we can still see the formula, just so you guys can see where everything is coming from. So we have our negative sign, we have b is 0, so I'll put a 0 where my b is. I'm going back and forth between the colors here. Alright, b squared, so 0 squared minus 4 times a times c all over 2 times a. So I just plugged all my pieces into there. You guys should be pretty familiar with how to do this by now. Now that we have plugged everything into our formula, we can go ahead and start simplifying. So I'll go ahead and do that down here. So negative 0 is just 0. Plus or minus. Now in my square root, I have 0 minus 4 times 25 is 100. So 0, ooh, that's real ugly. 0 minus 100 all over 2 times 1 is 2. So let's continue simplifying. This 0 honestly can just go away, so really I end up with a positive negative square root of negative 100 all over 2. So now we're getting there. I want you guys to be able to recognize that when you see a negative number under a square root, we do want to rewrite that in terms of i's. So the way you do that is you take the square root of that regular number and then you chuck an I at the end. So the square root of 100 is 10, and because it's a negative, we will put an I in there. So really, this is what we end up with, and you can simplify this further. You can actually do 10 divided by 2. So your answer is positive and negative 5i. Alright, so that tells me that here I'm going to write, well, these, but also I want to go back and start with the root I found in the beginning. So I have 3, I have positive 5i, and I have negative 5i. And these two I got from my quadratic formula. So in factored form, I have to just take all of these and use the opposite sign. So positive 3, we already talked about how that gives us a factor of x minus 3. 5i gives us x minus 5i. And negative 5i gives us a factor of x plus 5i. Okay, so again, this is the same exact process as we did in the last video, except this time the only difference is that we had some imaginary roots come out of the quadratic formula. And that is it. Go ahead and give the practice problems a try if you haven't already.